Yeah, there's 6 and then
Yeah.
4.
Yeah, because Anna was telling me she heard my voice one time, and I was like, oh, they must have their own video.
Yeah, I only video 3rd for 6th, and I video 1st for 7th and 4th for 5th. So in the afternoon, I can just write all over the whole board, but here I'm confined to this tiny space. So I wanted to remind you guys, I'll say what I already said. On this page, which is page 87 in the book, I may or may not, I remember in one class, but that could be any one of the 4 sections I teach. I remember mentioning this, but we didn't really go over it directly. Did y'all do this?
No.
I'm seeing some nod yeses and some nod no's. This is a big deal for APCAL. They always are giving you charts, and if you look at this chart, essentially I'm giving you what?
Oh,
A bunch of X values, and then the F and the G would be the Y values, so those would be points, right? So the point on F would be 2, 8, 3, 3. The point on G would be 2, 2, 3, -4, right? But what is this giving me? Those would be the slopes of the derivatives of this function. So they give you this table of values of F and G and the derivatives at 2 and 3. And then they come down and they ask you, well then what is the derivative of twice the function at 2? And what's the derivative of the function of F times the function of G at 3? Or the function of F plus the function of G at 3? So I just want to walk through a couple of those. So for instance, if I was going to do D, I'm going to do it up here so you can still see the table. How do I find the derivative? Remember, ddx just means the derivative of that. It would have to be the quotient rule. Now, a lot of people make the mistake of looking at this and going, oh, f prime over g prime. Don't do that. You know what the quotient rule is, right? So you would have to say, all right, well, the derivative then, the d dx of f over g is low times d high minus high times d low, all of it over the low. And you know you can write a function like this. I don't know if you know this, but you can write the squared like that. I don't know if you know that. A lot of people don't know that, but a lot of people feel more comfortable writing it like that. I don't care, and nor does AB. So that's the derivative, but they said the derivative when x is 2. Now the way you would write that in APCAL, and this is something you have to start learning and being really good at, because you remember, somebody's reading your paper, and they don't know you, okay? So they need to see it, and you could say the derivative, the ddx of f of x, of g of x, as x approaches 2 is, you could write that expression out, or you could just do this. ddx of what you're doing, and the way you say at 2 is you draw a vertical line, and you say x equals 2, and then equal. Now if it's a point, you don't have to say x equals, you could just write the point right there. So if it was, when we get to implicit differentiation, you're going to find that we have x's and y's in the derivative, or x's and t's, or something like that. And you would be plugging in the entire point in there, like the x value and the t value. So, but here it's just the x value. So I'm just going to come up here and plug a 2 into everything. So to plug a 2 in there, what am I going to need to find?
The function of x and f and g.
More than that, what else? I got to find g of 2, f prime of 2, f of 2, g prime of 2, and g of 2, and plug it all into that. So I'm only working with 2 here, but the first one is the g of the 2, and that is 2. So I'm going to plug a 2 in for that. And then the f prime of the 2 would be a third. Plug that in right here. And then the f of the 2 would be 8. And the g prime of the 2 would be -3. And then the g of the 2 would be, I've already done that, right? So I'm going to do that again, 2. But this time I'm going to square it, so 2 squared is 4. And then it's just a matter of cleaning that up. Now I know the 2 negatives are going to multiply together and give me a positive, so I'm going to go ahead and make that positive. And I could say 2/3 plus 24 over 4. But what was the hint I always gave you if you had a fraction inside of a fraction? If you weren't with me last year, you might not know that. But what's a good thing to do to a fraction if you have a fraction inside of one?
Everything but 3.
Multiply the top and the bottom by whatever that common denominator would be. It looks like my common denominator of these 3 terms is 3, 1, 1, so 3. So rather than actually adding those two numbers together, I'm just going to multiply the top and the bottom by a 3. And that gives me 2 when I distribute it in, plus 72 over 12, which is 74 over 12. And I personally, and then I can cancel junk. I know I can get a 2 into that. So 37.6. To me, that's easier than adding this and going, oh, what's my common denominator? 72 thirds, 74 thirds divided by a 4, multiplied by a fourth, 72, 12, I mean, whatever, 74, 12. You're still going to get there, but it's just, to me, it's uglier than just doing that. And I want to do one other one. Does that make sense?
Yeah.
What I'm doing? And then another one, if you look at C, this is probably the most popular one that AP would ask you about. It says the derivative of f of g of x. So that's not a quotient rule. I mean a product rule. What is that? That's like my chain rule, where I start with the f and work my way in. So on this one, I'm going to erase this, and I'm going to do e. And then we're going to take the quiz real quick. So on this, e says the d dx of the f of g of x at x equals 2. So first I'm going to take the derivative, then I'm going to find it at the value of 2. So to start this, what do I begin with? What do I do in the chain rule? Outermost. So if I'm starting with the outermost function, everything else on the inside, you just think about it as a blah, right? So that would be f prime of blah, right? So f prime of whatever my blah was, which in this case was g of x. And that takes care of the outer function. And you do that if it was a trig function of blah, or a big parentheses with a power, you go with the power. You do with that outer one first. Now I'm done with the f, now what do? G prime of blah, so times g prime, but the blah this time is just the x, and that takes care of the g. And had there been something on the inside, like 5x or 4x squared, whatever, then I would now take the derivative of the x, but in this case the derivative of x is just 1. So to do this, I now am saying, well, what is the derivative of this vertical line when x is 2? Please get in the habit of doing that. Because if I just say, hey, the ddx of f of g of x, and then I write my value there, I just said the derivative is 2 always. Is the derivative at any power of x 2? No, the derivative at 2 is. And the reason why you don't want to plug the 2 there, and I know a lot of people are like, why don't you just plug the 2 in there? Because what that's saying is to do is to find what f of g of 2 is, and then take the derivative of it. But wait, if I find what f of g of 2, first of all, g of 2 is 2, and then f of 2 is 8, and then I take the derivative. What's the derivative of 8? I get 0 every time, right? So literally, if you put a 2 there, you're actually writing it incorrectly. You need to say the derivative when the x is 2. So now what do? I literally have to plug the 2 in here. And then slowly simplify it. So what do you want to simplify first? So I'm doing f prime of g of 2. So go to the g of 2, which is 2. And then do the f prime of 2, which is a third. Y'all with me? So this part gives me a 2. Then I drop down the f prime. And then the f prime of 2 gives me a 1/3. And then the g prime of 2 is just -3. And then that just gives me -1. So just to expose you to these, don't freak out or think more of them than they are. And also understand that AP would probably say something like, I don't know. They would probably put something else in here. I'm trying to figure out a value that I could still use this chart with. I don't know that there is. Because if I put something like a 2x in there, then I would need to know g of 4, and I don't have the 4 here. But they would probably have a value with the x. Like they would probably have something like f of g of 4x. So that at the very end you have this, you have a 4x here and a 4x here, and then a times 4. So if I say, what's the value of if they had done this? I would need a different table. But if I had done that, f of g of 4x, I get a totally different function here, don't I? Because now when x is 2, what am I finding? That becomes a what? An 8 here. So if this is a 4x, it's really 4 times 2 is 8. 4 times 2 is 8. And I would just need a different table of values to be able to do this. But they would do something like that. And they would give you a table that could be both confusing and would answer your questions to either mess you up if you didn't acknowledge the 4, or take care of you if you did. So it could be trickier than that, but I just wanted you to see that before you started the quiz. And if you are at home, work on quiz number 1. You don't have to print it, but it's for you. It's on Schoology. The key is also there, but I will be going over a video of this key at the end of class, and I will be posting it later on today. All right, so here's our quiz. Hopefully you did well on it, but guys, listen, if you got beaten up, good. You exposed some weaknesses. You got to figure out what you did wrong. Please ask questions, and hopefully you at home, your questions will be asked by this wonderful class. So right here, give a general definition of the derivative using limits. Every year I have somebody write, oh yeah, it's the slope of a line tangent to a curve. That's great and a good definition, but you didn't use limits. So what is the definition of the limit? The limit of what? As h approaches 0 of what? The f of the x plus h minus the f of x over the h. And if you forget this, remember it's a slope. Remember when we were showing you at the very beginning, we had the 2 points, and we had y minus y over x minus x? Well, that's the first y minus the second y, and that's the first x minus the second x, but the x is canceled. Don't put times in here, don't put equal in here, don't do anything like that. Don't go x to 0, make sure you go h to 0. There's another one, though, that we mentioned, that is the limit as x goes to a number, we call it an a, of f of x, x, f of a. There was that one that we mentioned on the L'Hopital's day. So either one of them is fine. This finds the limit at a particular x value, so you're always going to get an actual answer, like an actual value. This is going to give you a formula. That is, unless they put x is 2 or something up here, and then it will give you the actual number. But either one of those is fine. What is a derivative? Okay, careful. It's not the equation of a line that's tangent to a curve, but it's the equation that represents the slope of the line. It's probably better not even to say equation, because it's the slope of the line that is tangent to the curve at a certain place. Okay? Or it's the instantaneous slope, the actual slope at that particular x value. All right? But it's not the equation of the line. We're actually going to do that tomorrow in class. I'm going to talk a little bit, I think. I'm always like a week and a half ahead, so I forget what video I've made, but I think I'm going to show you tomorrow how to use your calculator to calculate a numerical derivative, like a derivative at x equals 2. Your calculator can't, unfortunately, write the whole derivative out, but it can find what the slope is at a certain x value. So that's pretty nice, and your calculator will be used a ton on the AP test, probably half of it. So you really want to do it, understand that really well. But we'll talk a little bit about that and how to find the equation of a line that's tangent to the curve. And so for those of you that had me, we did that last year, so that might be floating around in your brain. So be careful of that. But right here, just slope of a line that's tangent to a curve at a certain point. Or the instantaneous slope or instantaneous rate of change at a place on the graph. All right, so from here on out, it's just actually making the actual calculations. So right here on number 2, to find the derivative of that function, where do I begin?
7.
So the outer function is the power. You're going to drop the 3 and go 7 blah 6, or 7 times 3 blah 6. That takes care of the 7 and the constant, but don't forget to put your blah in there. Also, if you're taking the derivative of that and putting that in the middle, that's what Show did. And we don't want to be like Show, prideful and not checking your homework and missing every single question on my test, which is essentially what happened to him. Then what? Chain rule says come back, take the derivative of the inside. So 15 x squared minus 4. Also, if you forgot parentheses there, you get dotted. You got to have parentheses around that to show that I'm multiplying by the whole thing. All right, number 3. What do we got going on there? That's as tricky as these trig ones will get. Do you begin with that 3, with the tangent, with the 5? What do you do? Yeah, because really the 5 there is kind of like it being out here. And you would go 5, blah, 4. But they don't write it that way. And you don't need to write it that way. You need to have good form. So you're going to go 5 times the front. Copy all of that blah down. Like all of that is kind of like your blah. So copy all that down. And then put the 4 back where the 5 was. And that takes care of what? The outer part of the function and the constant, which is the outermost function. Then you move to the what? To the tangent, not to the 3. The 3 is only with that. The tangent is with all of this. So what's the derivative of tangent of blah? Secant squared of blah. That I can't help you with. You're going to have to memorize that. Okay? But I can help you with all 6 of them. There's a couple little tricks we pointed out, some patterns that might be helpful. So the derivative of tangent blah is, so times secant squared of blah. That takes care of the tangent, and then just copy the blah down, which was 6x minus 7 cubed. Now I'm down to just blah to the 3rd power. So the 3, so 3 blah 6x minus 7 squared takes care of the 3, and then times 6. And you're fine to leave it like this on a test, although if it was the AP test, they would probably have the 20 and the 3 and the 6. They would probably have that all multiplied together, and they'd have a 360 out front. And then they would probably move that part right there, right behind the 360, and then they would write the tangent and the secant. Just saying. But for your test, we're just doing mechanics. This is the mechanics of derivative, not the application. So there's no need to clean it up in any way right now. All right, number 4 and 5. So on number 4, and by the way, if you had issues, I had somebody, I did a Google Meet yesterday after school at like, I don't know, 3:20 or whatever, just hopped on there. They asked me a couple questions about trig, and they were like, oh, okay. Sometimes you just got to fight through that. The order is weird, and you might need to see it again to kind of see that. So if you're struggling with the trig stuff, if you're struggling with memorizing the 6, I can't help you. You're just going to have to do that. But if you're, I can maybe help you a little, like I said, but if you need some practice to kind of help see it, once you see it, it's not a big deal. I mean, you'll be fine once you see it. All right, right here, is there anything before I start? I mentioned this, whether you were here or not, but I mentioned this on a video. Is there anything I could do on a log that might help you in the whole process, make it a little bit more simple? Yeah, I said that power, because of our log rules, allows me to swing that to the front. Now, if there's no log there, I can't swing it to the front, right? But if there's a log, I can, and that will eliminate one extra function I have to deal with and just make it a part of the constant. So I'm gonna, it's not the log, that's just, that's not the derivative, that's just a log rule. So that would give me 12 ln of 5x minus 2. So now to take the derivative of that, all I have to do is, well, drop the 12 down. And what's the log rule? It's technically du over u, but if you think through the process, it's copy that to the bottom. That takes care of the 12 in the log. And then the chain rule says take the derivative of that. But rather than write it out to the side, I just put it on the top. So it really ends up looking like du over u. Now, if I don't swing the 3 over, that looks a lot uglier. But this, 60 over 5x minus 2, is how this derivative would look on the AP test. If you don't swing it, you end up with this. Like if you didn't do all this, this is what your log would probably look like. You'd have a 4, and you copy this down to the bottom. Then you have 3, 5x minus 2 squared times 5. You're going to have that, and this is going to be on the AP test, and it's going to be like, what? And you'll eventually get there, canceling all that out. And this is on a simpler one. It could look a lot worse where you don't see it as clearly. But if you just swing that to the front, man, it makes your life a whole lot easier, I think. And then what's the rule on exponential functions? Copy them down. So if I just copy it down, of course we can drop the constant in that. If I just copy it down, what is that, second? That takes care of the derivative. The derivative literally is itself. Now technically there's an ln of the base in there. But what's the ln of the e? 1, so I don't have to bother. Had that been a base 4, I would have had to have an ln of 4, or a base 3, ln of 3. But I'm done with the derivative of e. Now I go take the derivative of the power, which is what? Sorry, that takes care of that. And what's that? 2 blah to the first times 3. And that takes care of that. And yes, on the AP test, it wouldn't look like this. You'd probably see a 36 there, and then the 3x minus 7, and then the E part. It would probably look like this. That's what it would look like, but I don't care about that. We're fine right here for now. Wow, we are really not going fast, are we? I didn't budget that well. Any particular one? I'll do this video, but I probably won't have a chance until 5th. There's a key on Schoology, but I'll put the video on Schoology. Dadgum, I thought I had 5 minutes. I looked at the wrong thing. Oh well, I'm going to be splicing this video together. Alright, so picking up here at number 6, let's take a look. And I'm going to try to talk less and write more. Do you remember the trick I told you about taking a derivative of a square root? It'll make your life look better.
Yeah.
What is it?
I forgot it's not the other way.
But you do remember me
I
saying
remember
it.
you saying it.
Yeah.
What do you do?
Inside of the derivative on the top.
Good?
And do like the 2 times the root on the bottom.
Perfect. You double that on the bottom. And then and then that's basically the rule. And then the chain rule says, oh yeah, go back and take the derivative of the inside. But rather than put it out to the side, I'm just going to throw it on the top. And it looks a lot better than what you end up with, a 1/2 blah to the negative 1/2 times the derivative of the inside part. And the problem is there's nothing wrong. Listen, if you did this and you wrote 1/2 blah to the negative 1/2 times 10x minus 3, that's right. But here's the problem. What happens later, and I know where we're going, but you don't. What happens later when I say, hey, tell me what the derivative is at x equal 2? It's going to make me a lot happier plugging a 2 in there and getting 20 minus 6 is 14, and it's square root of 4, or some other number, and it usually ends up being pretty, than plugging a 2 in there and going, oh crap, now what's a negative 1/2 power do? Oh, I got to move it to the bottom, then I got to change it to a square root, and I got to put this on the top, and the 2 ends up on the bottom. You're going to end up here anyway, trying to simplify. Why not just end up there at the very beginning? Did you do this? Awesome. Okay, so don't do that. Now, if it's a cube root, change it to 1/3. There are rules for cube roots, 4th roots, 5th roots, but they don't show up as much. This shows up all the time. So my genuine advice is to do this. Okay? Okay, what about this? Now, you can use the quotient one. I don't know why this bothers me, but for some reason when I see people write low d high minus high d low over low squared, I'm just like, ugh. I don't know why. It just bothers me. Is there really a need to do that? Doesn't it look a whole lot better if you do this? Low d high, oh yeah, the d high is 0, that's gone. So my brain just eliminated that thought. Minus high d low over the low squared. Doesn't it look a lot better? Because the answer on a multiple choice test, or AP test, will be negative 15 over this. And if you have all your junk on there and you're like, what the heck happened? It's just one more thing your brain's going to overload on. Now, if you move this up to the top and made it a negative 1 power, then what would you have as the derivative? Negative 3 blah to the what? Negative 2 times the derivative of the blah. But isn't that negative 15 over that on the bottom? So you could do that, but I think just it's one extra step to write this. I think it's better just to think low d high minus high d low, but then don't actually write the low d high if it's going away. All right, number 8. I told you I would ask you an 8 and a 9 on this test. I am going to do it, and then it'll be the last time I mention it. Maybe on your exam, maybe not. But if it's on your exam, it would be on your exam review, which is really long, and you'll have a lot of fun with that. But it is a pretty good exam review as far as preparing you for a test. But this, what do you have to remember about base 4 logs or base non-natural logs or non-E exponential functions? What's that extra thing you got to remember?
Add the ln.
Add the log of the, not add, but multiply or divide the log of that base. And on a logarithm derivative, you what? Divide by the ln of 4, and on an exponential derivative, you multiply by the ln of 5. Other than that, the log rule is the same. So here, the derivative, what do you do for the derivative of log? And is there something you might want to do first to make your life a whole lot prettier in the end?
Swing the 2 out.
Swing the 2. Does that have anything to do with taking a derivative? No, that's just the log rule, right? Now don't go start swinging 2s all. I have people like this, oh, I can swing the 4x squared minus 6x to the front. Or I give them something like this and they go, oh, I can swing that 4 to the front. No, on a log you can, nothing else. So yeah, why not? Swing that 2 to the front, and now it's just a constant. It makes it a lot easier to do this derivative. But once you swing it, it's not there anymore. So copy that 2 down, and then what? And I'll show you what it would look like if you didn't do that. And then what's my rule for taking a derivative of a log? Copy what you're logging to the bottom. And then in this special case, multiply by ln 4. And that's it. That takes care of your log. But you do have to now go back and multiply by the derivative of the blah. And technically you could put it out to the side, but since the side technically is in the numerator, I just put it in the numerator. So 14x minus 6. Now if you don't move the 2, this is what your answer would look like. If you don't move it, this 2 wouldn't be there initially. You would copy this down to the bottom, which would be squared. And then when you take the derivative of this, you'd have 2 blah to the first times the derivative of that blah, which is this. But you have this really ugly problem, which is going to simplify down to what we just had originally, isn't it? So why not just move the 2 out in the very beginning, and then you don't have to worry about it. Makes it a lot easier on a multiple choice test where you're not going to have to clean it up. Although you won't have to. On this test, actually, I very well may give you a log problem and say, write your most simple answer. So if you do it this way, you're going to have to cancel a bunch of junk. All right? Now, technically, I would need to multiply my 2 in, but what about over here? Exponential. So just copy it down. Times ln of 5. That is the derivative of the exponential function. That takes care of that and that. The chain rule says, oh yeah, now go back and take the derivative of that. What am I doing wrong here? Yeah, this looks like I'm multiplying that times the 8x and then subtracting the 6. Don't forget. All right, what about this right here? Oh man, limits problems. He said this was a derivatives test. Why would this be on here? It's either the definition of a derivative or just a L'Hopital situation. So at this point, I'm a fan of L'Hopital's rule. Like, I recognize that that is a definition of a derivative at x equals 7. But man, who cares? I plug in a 0, 1/7 minus 1/7 over 0 is 0 over 0. Let's do L'Hopital's. What's the derivative of that? Low d high tells me what? The d high is 0, so that's going away. Minus high times d low. What's the derivative of the low part? 0 plus 1. So times 1, that doesn't change anything. Over the low squared. Okay? What's the derivative of 1/7? And what's the derivative of h? 1, redo the limit. I didn't even think about definition of a derivative, did I? Well, when I plug the 0 back in, I get 7 squared on the bottom, so negative 1 over 49. Same thing over here. Normally, I would either have to recognize that that is a definition of a derivative, or I'd have to multiply by the conjugate. Remember that? Multiply by the rationalize the numerator, all that garbage. You don't need to know it anymore. Check it out. I plug a 7 in, I get 4 minus 4 over 7 minus 7. And if I get 0 over 0, just like I did here initially, I can do L'Hopital's rule. There's one other time I can do L'Hopital's. If I get what? Infinity over infinity? Whether there's a plus or minus, doesn't matter. And then there are some other things that we could do it with, but we don't cover those in AB. But like there are other indeterminate forms that BC Cal would know about. You'll figure them out in Cal 2 if you should have to take Cal 2. All right, so anyway, how do I do this? What's the derivative of that part? Now that we know our little secret method, it's so much easier, right? Double that on the bottom. Derivative of the inside part on the top. The derivative of the 4, nothing. The derivative of the x, 1. The derivative of the 7, nothing. Redo the limit. And now, look how nice it is to plug that in there. Look at that. Square root of 16 is 4. 4 times 2 is 8. I get a 1/8 minus nothing over 1. Child's play. Right? So if you wish you could go back and take the derivatives test, huh? All right, what about number 12? How am I doing? Am I going to make it? 215? So number 12, calculate the derivative here. Can I go swing that 7 out in the front?
No.
I see it every year. Remember, only on logs. All right, where do I start with? The 7, the 4, trig function, the 3, what? I start with the what? The 4. And we talked about that because that 4, that's where math people put it. But what it really means is all of that to the 4th. So it's like a big power rule first. So 4 times the 3 is 12. But all of this is my blah. So 12 blah to the 3rd. And I put the 3rd back where the 4 was. But that only takes care of what? The 4 and technically the constant. Now what? What's the derivative of cosecant? Negative cosecant blah cotangent blah. Every year I see negative cosecant x cotangent x. Negative cosecant blah cotangent blah. And then what did I write wrongly here? Looks like I'm subtracting. So remember, I am multiplying by a negative. That takes care of the cosecant part, and then you're kind of hung free at this point, right? So the 7 would be 7 blah 6, and then finally times the 6. And I would really want to clean this up if this was a multiple choice question, but we're not worrying about that on this test. Like I would want to go 12 times the negative 1 times the 7 times the 6, put that out front. Then I would want to put this power thing out front, and then I would start lining up the trig stuff. Like I could even combine that cosecant cubed and that cosecant, do a cosecant to the 4th. We're not going to do any of that right now. We'll worry about that later. And then what's our rule for absolute value? Haven't seen much of those, have we? You remember the rule? We talked about it. What? Absolute value goes on the bottom. The inside part on the top. And then the derivative of the inside part on the top. And that's my derivative. And if I needed the derivative like at 2, then I would plug a 2 in, but right now I'm good. Stop right here. And then this looks a lot like we just were talking about earlier, right? So it asks you for the derivative. If that's h, what's the derivative of h? So the derivative of h would be what? Low, d high, minus high, d low, over low squared. And by the way, do you know that you can write a function squared by putting a 2 there? If you don't know that, you can. A lot of people are like, they don't like that because they've never seen that much. That's fine. But then to take the derivative at 2, I would say the derivative of h at 2, but I'm going to label that. I'm not going to put equal and then plug a 2 in. Do you see that? We don't want to do that. That makes APT graders cringe. They're like, no, the derivative is not this number. This derivative is that. The derivative at 2 is this number. So make sure you're labeling that stuff. And if it's a ddx thing, you put the line with the x equals 2. But here you're fine to do that like this. Okay? So what is this derivative at 2? G of 2, 5. F prime of 2, 3. F of 2, negative 4. G prime of 2, 5, and then g of 2, 5 squared. So 15 plus 20 over 25. Would y'all get 7 fifths? 5 minutes. It's going to be close. All right, so this f of g of x, how do I take a derivative of a composite function? Start with the chain rule, the outside. So I'm going to start with f prime of the blah. And then I'm going to take the derivative of the inside of the new blah. And then I'm going to take the derivative of the blah, but that doesn't really matter. And then now at 3, how do I write this? The derivative of f of g of x at 3 would be what?
The derivative.
It'd be all of this. Just plugging a 3 in and then slowly simplifying. What's the g of 3?
2.
2. Put a 2 there. What's the f prime of 2?
3.
Back to a 3. What's a g prime of 3?
4.
4. And then 3 times 4, 12. And then the bonus says, love to get that higher here. Says find the second derivative. I don't know that we talked about that in a video or in class, but there might have been a homework problem. I snuck it on you. But the second derivative just means take the derivative and then take the derivative of the result. So let's do the first derivative first. I'm writing up here so that you can see it better. So the first derivative we technically just did on this problem, right? So it's f prime of blah times g prime of blah times 1. So the second derivative would be the derivative of this. Well, now I have this function times this function, which is a product rule. So let's see if we can do this. First, times the derivative of the second. What do you think the derivative of the first derivative is? The second derivative. Does that make sense? Now, for those of you like, I don't know what a second derivative is. We'll talk about that later, but does that kind of make sense? A derivative of a first derivative is the second derivative. And then plus second times the derivative of the first. So how do I take a derivative of that? Still a chain rule. So I take the derivative of the outside part, which would give me f double prime of blah, f double prime of the blah, and then I take the derivative of the inside part, which would give me g prime of blah. And then I would plug in a 3. So the second derivative at 3 would be what? I'm just going to try to do it as much as, so I want to finish. What's the g of 3? G of 3 would be, man, I can't see this. G of 3 would be 2, and then f prime of 2 would be
3.
F prime of 2 would be 3. So all of that becomes a 3. G double prime of 3 would be what? Negative 6. G prime of 3 would be 4. G of 3 is 2, but then f double prime of 2 is negative 8. And then G prime of 3 is 4. And then I just got to be careful. Negative 18 minus a what? 128. So negative 146. Anybody get that?
Yes.
But that would be a bonus at this point in the game. How are we feeling?
What's the definition of it in your own words?
Oh, in my own words, I would say either one of two things. Slope of a line tangent to a curve at a particular value. Or say the instantaneous rate of change. That means the slope at a... And then the guys with the limits on that number 1, if I say use a limit definition, guys, you have 2 options. This one, which most people go with, or this one, which is that alternate definition. Most people go with that one. Y'all have a good one.